we can start the aldehyde. Yeah, obviously, we'll start the aldehyde, ketone, and carboxylic acid. It's a very important chapter in organic chemistry.
Okay.
Very, very important chapters in organic chemistry.
Yes,
Aldehyde,
sir.
ketone, and yeah,
It is
carboxylic acid.
chapter, I think, right?
Yes. So I think you are able to see the screen. Am I correct?
Yes, sir.
So we have to do the aldehyde, ketone, and carboxylic acid. Aldehyde, aldehyde, ketone, and carboxylic acid. Carboxylic acid. So when we talk about aldehyde, so in aldehyde, you can see the functional group C double bond O. Listen, if
Sir,
C, yeah,
sorry, sir. This can you change it to a white background, right? Because afterwards I can use it for taking printout or something.
so you wanted to take the printout.
Yeah, because this black screen it is difficult.
It's a very difficult. So let me change the, how can I change? Yes.
Sir, I think from that layout, yeah, from there I think we can change.
Is it fine now?
Sir, but it looks like very colors.
Yeah, I will change the color. It doesn't matter. Okay,
Okay.
I will change the color. So we have to, now I think black colors.
Yeah, now it
Is
is.
it fine? Hmm.
Yes.
So we have to do the aldehyde, ketone, and carboxylic acid. Am I clear? So
Yes.
your favorite color is blue, so I'm taking blue. So here this carbon double bond O. This carbon double bond O group is called carbonyl group. This one is carbonyl group. This is carbonyl group. This group is called carbonyl group.
Yes.
And if you put C double bond O, this side one hydrogen and other side, if you are writing alkyl group or aryl group, alkyl group or aryl group. Aryl means benzene, aromatic ring. So now it will be aldehyde. Aldehyde. So aldehyde means CHO. This is this CHO. This is the main functional group. Symbol for this aldehyde is CHO. And if there is one carbon chain, so this is aldehyde. If there are two side carbon chain, so this will be ketone. If you are writing C double bond O carbonyl group, and if you are writing this side carbon chain and this side also carbon chain, this carbon chain will be like or unlike. R should be equal to R dash or should not be equal to R dash. But if this carbon, this is carbonyl carbon. So this carbon is called carbonyl carbon. Carbonyl carbon. And if this carbonyl carbon has two alkyl chain, two carbon chain, alkyl or aryl, this is R dash carbon chain. So this will be considered as ketone. So this is ketone. And if there is only one carbon chain, so this is aldehyde. This is aldehyde. Now, if this carbonyl carbon have one side alkyl chain carbon chain and other side OH. C double bond OOH. So now this is called carboxylic acid. Carboxylic acid. So to identify aldehyde, ketone, or carboxylic, first you have to check that this carbonyl carbon has how many side chain. If this carbonyl carbon has If this carbonyl carbon has one side R, other side OH, this will be carboxylic acid. If this carbonyl carbon has one side R, other side also R, carbon chain, aliphatic or aromatic, so this will be ketone. If carbonyl carbon has one side R, other side hydrogen, so then only it will be aldehyde. If both side HH, it will be again aldehyde. Like if you are writing this carbonyl carbon double bond O, and this side if you are writing H and H. So this is called formaldehyde. And this formaldehyde is the smallest member of aldehyde, formaldehyde. If you are writing CH3 and then C double bond OH, so this is called acetaldehyde, acetaldehyde. If you are writing CH3, C double bond O, C H3. So this is called as ketone, and this ketone is because carbonyl carbon has two carbon side chain. So now this is not aldehyde, this is ketone, and this ketone is called acetone. This ketone is called acetone. So
Yes.
at least for in the case of acetone, at least three carbon required. This is the IPSC name for this one is propanone. So for ketone, the suffix one, on can be used. So this is propanone. This is propanone, IPSC name. And the name of this compound is acetaldehyde. In the case of aldehyde, the suffix will be used al. So two carbon, carbon number one, carbon number two is called ethane and al, ethanol. And one carbon is methanol, methanol. So in the case of aldehyde, we will write we will write al, and in case of ketone, we will write on as a suffix in IPSC nomenclature. But if you are writing CH3 and C double bond OOH, so this is called acetic acid, vinegar, acetic acid, and IPSC name, this is carboxylic acid. Why? Because this is C double bond OOH, match with this one, carboxylic acid. So IPSC name will be carbon number one, carbon number two. Two means ethane, oic acid. In case of carboxylic acid, IPSC nomenclature, suffix will be oic acid. Oic
Yes.
acid. Any confusion? Any confusion?
No,
No
sir.
confusion. Hmm. Suppose there is a benzene, and in benzene, suppose there is C double bond OH. So this is carbonyl carbon. And this carbonyl carbon has one side hydrogen and other side aromatic ring. So this is aromatic aldehyde. So aromatic ring is called benzene and CHO is aldehyde. So this is benzaldehyde. The name of this compound is benzaldehyde. It's a benzaldehyde. If you are writing this is C double bond OOH, it's a carboxylic acid. Why? Because this side OH and this carbonyl carbon has this side aromatic ring. So this is called what?
Carboxylic.
Benzoic benzoic acid. Benzene oic acid. So it's a benzoic acid. It's a benzoic acid. Any confusion?
No,
Any
sir.
confusion? Hmm. So the very important thing is what to identify the aldehyde, ketone, and carboxylic. So in the case of aldehyde, CHO is there. In the case of ketone, the middle C double bond O carbonyl carbon has two side carbon chain. In the case of carboxylic, the middle carbonyl carbon has CH3, means carbon chain, and other side must be OH. Clear? If carbonyl carbon, it's not in your syllabus, but you should know. If carbonyl carbon, if carbonyl carbon has C double bond O and other side is carbon chain, and this side is suppose X. X means halogen.
Yes.
Halogen. X means halogen. Chlorine, chlorine, bromine, iodine. So now this is called acyl halide. This one is acyl halide. This is called acyl acyl halide. You should know acyl halide. And if this carbonyl carbon has this side R and other side O R, so this is called ester. This is
Yes, sir.
called ester. And if this carbonyl carbon has this side R and other side again carbonyl carbon, and both carbonyl carbon are separated by oxygen atom. Both carbonyl carbon separated by oxygen atom, and there is another R. So this is called acid anhydride. Acid anhydride. Acid anhydride. Acid anhydride. It means carbonyl carbon has one side R, other side OCOR. So this is called acid anhydride. Are you getting what I'm trying to say?
Yes, sir.
If carbonyl carbon has one side R and other side NH2, so this is called amide. You should know that this is amide. Am I clear? So this
Yeah.
is what? Amide. Fine?
Yes.
Okay. So when we talk about the nomenclature, so we should discuss the nomenclature or in the exercise question will do.
Yeah, in the exercise questions we will do, sir. That
Hmm.
example questions are also there.
So we should start the preparation or we should do some IPSC nomenclature of the compound.
Sir, let's do some nomenclature questions.
We should do the nomenclature.
Yes.
So you can see the nomenclature, nomenclature of aldehyde and ketone, aldehyde and ketone.
Sir,
In the
you
case of,
told that.
sorry, yeah, tell me
Sir, I was saying that you were telling on that now, right?
what I am telling.
Sir, you already told that, right, about this ketone and aldehyde, what to do, nomenclature.
Nomenclature already we have done, but some new compound we'll see, like
Okay.
complex structure. So,
Okay.
so in the case of aldehyde, the suffix which we will use that is al, and in the case of ketone, the suffix which we will use that is one, on, on. Clear? Like suppose if I am writing, it's suppose uh, there are two nomenclature. The first one is the common nomenclature, and second is the IPSC nomenclature. So if you are writing like CH3, CH, CH2, CHO. So this CHO is aldehyde. CHO is aldehyde. CHO is aldehyde. And C double bond O, both sides are carbon chain. So it will be ketone. So here, this is aldehyde. And if I am writing here Br, iodine, chlorine. So this is the functional group. And this functional group contain this functional group. This is the functional group. What is the functional group? So the atom functional group is what? The atom or group of atom which decide the chemical property of the compound. So it's a functional group. And if functional group itself has the carbon, so this is called terminal functional group. So this one is called as a terminal functional group. So this is terminal functional group because itself the carbon of aldehyde involved in the carbon chain. So we'll start the numbering from here. This is the carbon chain. So
Okay.
this yeah. Now this is carbon number 1, 2, 3, 4. So on carbon number third, there is a 3 bromo, and 4 is called bute, and single bond is there. See that this carbon chain has the single bond. So this is AN, and E will be removed, and suffix ul will be added because CHO is there, aldehyde is there. In the case of aldehyde, we will add ul. You are knowing the rule of nomenclature, or I should discuss?
Yes, sir, I know.
You know well. Okay. So first, Hana, we have to do like this because when we talk about the rule of IPSC nomenclature, so first we have to write the primary prefix. First, we should write the prefix and prefix. Then after prefix, we have to write the main carbon chain, main carbon chain, method probute, and then suffix. We will write the suffix. There will be two suffix. One is the primary suffix and then secondary suffix. Primary suffix is always ane, ene, and yne. N in I. Carbon carbon single bond N, carbon carbon double bond in, carbon carbon triple bond ine. And secondary suffix is always the functional group. Secondary suffix is always the functional group. And you know the functional group. For aldehyde, we will use al. For ketone, on. For carboxylic acid, oic acid. And out of
Yes.
all these three, carboxylic acid is senior functional group. So this is the format. This is the rule, and we have to follow this rule for the nomenclature.
Sir, in the prefix
Now,
part,
for in the case of prefix, if you are writing a carbon chain, so in carbon chain name, add YL, like CH3 is there, so one carbon is meth, so add YL, methyl. C2H5 is there, so two carbon is eth, so add YL. So methyl, ethyl, propyl, pentyl, like this. So we have to add YL as the suffix. Are you getting what I'm trying to say in the case of prefix? And this
yeah.
prefix will be the not the main carbon chain. It's a side chain. This prefix will be the side chain. It's a side chain. Now main carbon chain you are knowing that methane, probute, pent, hex, septox, non-deck, undeck, dodeck, trideck. Are you knowing the main carbon chain?
Yes, sir.
Are you knowing the main carbon chain?
Yes, sir. Yes.
Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, 7, 8, 9, 10. Aiza, are you able to hear me?
Yes, sir, I can hear you. I can hear
I
me now.
can't hear you.
Hello? Sir, can you hear me now?
Am I audible?
Hello?
You are trying to speak, but yes, Aisha.
Sir, can you hear me?
Just a minute.
Sir, now can you hear me?
Yeah, I can hear you.
Okay. Sir, I was talking,
Yes,
but I think you couldn't hear me.
chalo. I think.
And now is it clear?
Yeah, I can hear you. Fine. Yeah.
Okay.
Are you able to see the screen?
Yes.
So the main carbon chain, one carbon chain is called meth, two carbon is eth, three is prop, four is but, five is pent, six is hex, hept, oct, non, dec, and 11 is undec, 12 is dodec, like this. And if single bond is there, so A and E, double bond E and E, triple bond Y and E. The E will be dropped. This E can be dropped. E can be dropped when secondary suffix start with vowel. If this is start with vowel, secondary suffix, like for aldehyde we are writing na, al. So there is vowel A. Ketone, C double bond O. It's O N E. So vowel is O. COOH. For this we will write oic acid. So O is vowel. When you are going to add the secondary suffix, just remove the E of primary suffix. So when you apply the same rule for this carbon side chain, carbon, 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 and suppose there is C double bond OH, aldehyde.
Yes.
So I'm not writing the hydrogen, you can write the hydrogen.
Okay.
So here it's a, suppose I'm writing bromine, here chlorine, here again bromine. So start numbering from this side, carbon 1, 2, 3, 4, 5, 6. So this is main carbon chain and this is side chain. Bromine, chlorine, bromo. These three are the side chain. So side chain is the primary suffix.
Yes.
So bromo present on third and 5. 3, 5 dibromo and 4 chloro. And total 6 carbon is hex and single bond is AN and eco just you remove and add al. So see that this is prefix and this is, all these are the prefix and hex is the main carbon chain and AN is the primary suffix and al is the secondary suffix.
It's a
It's a
primary
second.
is dibromofluoro, right?
Yeah, yes.
Okay.
So if many prefixes are there, so you can arrange them in alphabetical order. Okay. Hmm. Now you can see that if I'm taking the example of suppose CCC and CHO if you are writing. So IPSC nomenclature IUPSC. Nomenclature will be 1, 2, 3, 4 carbons. So it's a butanal. Butanal. But common name will be, this is the functional group and the functional group attached to the carbon is called alpha carbon and vicinity of this alpha is beta and beta adjacent carbon is gamma. So alpha, beta, gamma. So you can I means identify the carbon if I am writing the compound like this, and now double bond OH. This is aldehyde. And if I'm writing here bromine, so what would be the common name? So in the case of common name, you will use the alpha, beta, gamma. Don't use the 1, 2, 3. So this is the carbon and this is the entire one is the functional group. So the functional group attached to this carbon, which is called alpha, and this is beta, this is gamma, and this is delta. So bromo attached to the alpha. So it will be alpha bromo, and total how many carbons? So 1, 2, 3, 4, 5, 6 carbon. So 6 carbon is hexanal. So you can write this one or hex hexane aldehyde. Also you can write. So this is alpha bromohexanal, or you can give the IPSC nomenclature IUPAC. In case of IPSC, you can use the 1, 2, 3. So 1, 2, 3, 4, 5, 6. So 2 bromo. You can write here 2 bromo hexanal. Hexanal. Here also you can write hexanal dehyde. Hexanal dehyde. Also you can write hexanal dehyde, aldehyde in common nomenclature. After this, alpha
Okay.
bromo hexanal dehyde. Okay.
So in IUPAC we can't.
Sorry.
In IUPAC we should only write AL, not aldehyde.
Yeah, yeah, you can write aldehyde.
No, I'm
In
asking
case
for
of
PSCs.
in case of IPSC nomenclature, you can write al, not
Oh,
aldehyde.
okay.
Aldehyde when you will use, suppose if I am writing here C double bond OH, CH2, CH2, and C double bond OH. So you can see that double aldehyde. Two aldehyde groups are there. 1, 2, 3, 4. So this is 4 carbon is butane and 1, 4 diol. Butane 1, 4 diol. 2 times aldehyde. But if I am writing here 1, 2, 3, 4, 5 carbon, and here I am writing CHO. Here I am writing aldehyde CHO. Here also I am writing CHO. So if you are numbering the carbon chain from this end to this end, so this aldehyde will be left, which is not possible. If you are going to select the terminal functional group carbon, so all the terminal functional group carbons should be included the main carbon chain. Otherwise, don't include any carbon chain. So if you start from this end to this end, so this carbon left. If you
Yeah.
start from this to this, so this carbon left. So in this case, what you will do? In this case, just you leave it, and what you can do in this case, you just select the main carbon chain, leave this carbon of functional group, and this is 1, 2, 3, 4, and 5. So if the carbon of aldehyde is not included, not the part of the main carbon chain, so don't add al. You have to write now aldehyde or carbaldehyde. Carbaldehyde. So the 5 carbon is spent, and since single bond is there, so write AN E. E. Don't remove E because carbaldehyde start with C, not vowel. And
Oh,
1, 3, 5. Tri. Tri means 3. Carbaldehyde. Carbaldehyde. So this is the nomenclature of aldehyde. I hope have you got it.
sir, can you
Got it?
explain? this butane 1,4-diol. Then once again.
Butane 1,4-diol. I'm taking the another example, suppose, or let me explain it. It's a CHO. This is one carbon to another carbon. So here the terminal carbon carbon of terminal functional group included the main carbon chain. So if the carbon of functional group included, then it become but. So don't write carbaldehyde. You just write al for this type of aldehyde. And carbon number 1 and carbon number 4. 1 and 4 contain al two times. So for 2 it's a di and aldehyde al. Have you got it?
So here, why can't we write it like CHO and CHO? We can write it as side carbon chain and like the carbaldehyde which you wrote here.
So CHO you can write, but you have to maintain the tetravalency. Suppose if you are saying that, can we write like this? CHO. Now here the middle carbon cannot have CHO. The CHO will be either at the first or at the last because it's a terminal functional group. If you are writing carbonyl double bond O, so now this is ketone. It's ketone, not aldehyde. So either you have to write at the last or at the first. Have you got it?
So then, how is this pentane 135 tricarbaldehyde possible?
Pentane 1,3 uh, carbaldehyde is possible because if you are writing here CHO and side chain if has C double bond OH, here side chain has C double bond OH. So in this case, first you have to select the longest carbon chain. So the functional group is terminal functional group. So if you are moving from here to either this side, or if you are moving from here to this side, or if you are moving from here to this side. So in this case, you include only two carbon of aldehyde. In this case, only you include two carbon of aldehyde. Are you getting what I'm trying to say? If you are selecting this one, so only two carbon. What about this aldehyde? Question comes. So in this case, if CHO is more than 2 and if you are selecting the main carbon chain, and in this case all the carbon of functional group is not included as the part of main carbon chain, so leave out the carbon of all aldehyde. Just leave out, leave out, leave out. So select the main carbon chain now. So carbon 1, carbon 2, carbon 3, carbon 4. This is main carbon chain, I think. So in this case, the carbon of this aldehyde is not the part of main carbon chain. So you will use carbaldehyde for this one. Carbaldehyde. In the first one, you can see here on the here, the carbon is the main carbon is the part of main carbon chain. So here I have used the al. And if carbon is not included in the main carbon chain, so the suffix will be now carbaldehyde. So carbaldehyde present at carbon number 1 two times. See, carbon number 1 carbaldehyde, and carbon number 3 carbaldehyde. So how we'll write? We can write here 1 1 1 1 3 1 1 3 tri carbaldehyde, tri carbaldehyde.
Sir,
But
you
this
wrote 1,5.
but this will be as the suffix. And how
Okay.
many carbons are there? 4. So before this, you write but. And since single bond is there, so you write An. And don't remove E. Write the E. Why? Because carbaldehydes start with C, not vowel. So butane 1,5,3 tricarbaldehyde. Have you got it?
Sir, but like, why can't we take this the first CHO group in it and make it pentane? Because it will become a longer chain, right?
So if you take the first aldehyde, so what about the other two aldehyde? So rule is saying, IPSC nomenclature is saying, in the case of terminal functional group, either you include all the functional group carbon or leave out all the functional group carbon. Don't
Sir,
consider
what
one or two.
mean carbon?
Yes.
Sir, what terminal carbon group means?
Terminal functional group, it means the terminal functional group is C double bond OH, C double bond OOH. Terminal functional group always present either at the end of the carbon chain or at the beginning of the carbon chain. This terminal functional group you can't find at the mid of the carbon chain.
Okay.
Hmm. Because already three valency, you can see carbon has three valency. So the next fourth valency will be attached to the next carbon.
Okay.
Okay. So this is the terminal functional group. Terminal functional group.
And
So the same way you can do for the ketone. This ketone is not terminal functional group. You can shift. You can write ketone here. You can also write ketone here. You can write ketone anywhere. So it's not terminal. So in the case of ketone, you have to write ONE. Start the numbering 1, 2, 3, 4, 5. So it's a pentane and 2 ONE. Here it is. Can you tell me what is the nomenclature of this second one? Yes. For second
yes,
one, what is the nomenclature?
second one we'll name it from yeah, the last one. So 1, 2, 3, 4. So it will be butane,
Hmm.
uh, 2 ketone.
2
Sorry,
ONE, not ketone.
one sorry.
The last one, third.
Yeah, this one it will be 5 carbons are there, so pentane.
Hmm.
So it will be pentane. Yeah,
Pentane.
pentane 2 comma 4 dione.
Wonderful, Isa. Wonderful. So this is the nomenclature of the ketone. Am I clear?
Yes, sir.
If I'm writing double bond, suppose. If I'm writing here double bond and then CHO. Now what is the nomenclature of this compound?
Okay. So more priority is given to the functional group, right?
Yes, first functional group, then double bond, then triple bond, then substituent.
Okay.
Hmm.
So we'll number from the CHO group.
1, 2, 3, 4, 5, 6, 7.
Yeah. So it will be yeah, hep
Hmm.
3 in
3 EN, just remove E.
yeah,
And
hep 3 in then L. Yeah.
Kept 3 in L. Am I clear?
Yes.
Good. Example 5. Suppose if I am writing, tell me what is the naming of this compound. Start numbering.
So
Carbon
yeah,
1,
CO.
2, 3, 4, 5. So it will be what? 3-methyl.
Yeah,
In
3
total,
pent.
3-methyl. And it's a pent or cyclopent?
Oh yeah, cyclopent. Oh
Pentanone. Cyclopentanone. Am I
yes,
clear?
yes.
Now tell me what is the nomenclature of this one? It's a benzene, C double bond O, CH2CH3. Tell me.
Yeah, so we'll start numbering from the ketone group. So
Mm-hmm.
it'll be prop.
Yes. 1, 2, 3.
Yeah,
So this will be the substituent,
yes,
and substituent benzene is phenyl. In substituent, we will tell it one
yeah.
phenyl, and 3 carbon is pro, and single bond is there. So AN, remove E, and first pay on. So 1 on. Any confusion? Any confusion?
Uh, we can't write one benzyl.
No, no, don't write benzene. Listen. In the case of benzene, see that this is benzene, and benzene word we will use as suffix, and as prefix you have to write the phenyl prefix. Clear? So this is as prefix because this benzene is not part of the main carbon chain. You selected 1, 2, 3, 3 carbon. So this benzene is the substituent. So we'll use the prefix for this one. Am I
So
clear?
asking benzyl.
No, don't write benzyl. Benzyl is not that one. Benzyl is this one. If benzene is there and if you are writing CH2. So this is benzyl. This is benzyl. If you are writing complete CH3, so this is toluene. Okay?
Okay, so benzyl means CH2 attached to the benzene ring.
Yeah, CH2 when attached to the, so now it become benzyl. In
Okay, okay.
aliphatic carbon, you can add YL, ethyl, ethyl, propyl, butyl, pentyl. Not in aromatic.
Okay,
Am I clear?
so
Now we have to start the this in text question. May you can do it. We have to start the structure of carbonyl group. Structure of carbonyl group. Structure of carbonyl group. So
yes,
we are knowing that carbonyl group is this one, carbon double bond O. So this is sigma bond, this is pi bond, this is sigma bond. So here there are total 3 sigma bonds. So hybridization H is equal to sigma bond plus lone pair. So 3 sigma and lone pair 0. So coming 3, it means 1 s orbital and 2 p orbital, sp2 hybridization. So this carbon is sp2 hybridized. So the carbon is sp2 hybridized here. So
yes,
in, yeah, so in this case, in sp2 hybridization, the shape should be triangular planar. Triangular planar. So you can draw the structure of this one. This is carbon, double bond oxygen, and this oxygen has two lone pair, and this carbon has this one. Okay, and one vacant orbital is there. So if you want to make one vacant orbital, you can make it. So this is sigma bond, this is pi bond, this is another sigma bond. So one s and three p orbitals. So sp two hybrid orbitals are there, and this is triangular planar. So if you draw the structure, so see that this is the plane, this is the plane, and bond angle is coming 108 degree, sorry, 180 degree, and 120 degree, and it's a triangular planar.
Sir,
Triangular, yes,
sir, is it triangular planar or diagonal coplanar?
trigonal coplanar. Yeah, coplanar means all bond present on the same plane. So you can use both the term, no problem.
Okay, sir.
Hmm, clear? Now, you can do the in-text question.
Yes, sir, I will do.
In-text, in-text question will be homework.
Okay,
Okay,
sir.
you have to write the structure. Like if you have NCRT book, so you can check it. That the first question is alpha methoxy propionaldehyde. Just here it is given alpha methoxy propionaldehyde. So
Yes,
propionaldehyde means propional means three carbon, one, two, three, and aldehyde, C double bond O H, aldehyde, and alpha methoxy. So alpha means this is alpha, this is beta. So at alpha you can write OCH3. So this is methoxy. So alpha methoxy. Then you can write the hydrogen, and then CH3. This is the structure of the molecule. Any confusion? Can you do
no,
it?
sir. Sir, alpha means like the carbon which is next to the substituent group or functional group.
Function. Yeah. Yes. Yes.
Okay.
Yes. Here, in the case of fifth one, see, in the case of fifth, it is written di secondary butyl ketone. So di-secondary butyl ketone. It means di-secondary butyl ketone. So butyl means 1, 2, 3, 4. 4 carbon. And di-secondary butyl ketone. So secondary butyl means uh, here double bond O. You can write double bond O and secondary butyl. Now it's a ketone. Functional group is there. And di-secondary. Secondary butyl, are you knowing what is the secondary butyl? Acha. Don't write the first 4 carbon because it's only direct ketone is written. First try to make the secondary butyl, di-secondary butyl. The first you write secondary butyl. So
Okay, sir.
secondary butyl is what? Carbon having, this is secondary butyl. Why it's a, it's not secondary butyl because this is secondary butyl. Just a minute. This is secondary butyl 1, 2, 3. Secondary means 4 carbon. You can take it 4 carbon. It's a butyl, and this is double bond O. So butyl, this is secondary butyl ketone because it's a secondary carbon. Carbonyl group is secondary, but here it is written di-secondary carbonyl. So di-secondary means you can write here. This is one, and di, it means you have to write the another carbon. This is one, the same type you can write here.
Okay.
Uh, like this. Carbon, this is carbon, carbon, and then butyl. So you can see that this is secondary butyl. Why secondary butyl? Because the carbon attached to the carbonyl group, this carbon is secondary carbon. It's a secondary carbon because two side carbon chain is there. This is also secondary carbon because not secondary, it's a now it become tertiary. But here in common name, see that this there is only one side chain and one side chain. So two side chains, so this is secondary. But including this, it become tertiary. So it's a secondary butyl, and this is also secondary butyl. So di-secondary butyl ketone, C double bond O. Have you got it? You can write the
Yes.
head. So this is about the structure, about the nomenclature of aldehyde and ketone, and after this we have come to explain the method of preparation of aldehyde and ketone.
Sir,
Okay.
once again, this um,
Yes.
the small topic is left under the structure of carbonyl group.
Sorry.
So the small topic is left under structure of carbonyl group part, which is electronegativity, polarity, and that one.
So polarity wala part I will explain in the chemical property. So in the chemical property there is, see the polarity in carbonyl group. When we talk about the polarity, so this is C double bond O. So out of carbon oxygen, tell me which one is more electronegative?
Oxygen.
Partial minus, and this is partial plus. So it
Yes.
become polar. Now you can see that if you break this bond, so oxygen always carry minus charge and carbon will carry positive charge. Why? Because oxygen is more electronegative. So electron will shift towards the oxygen. So bond will be polar.
Okay.
Clear? Because oxygen is more. So here, due to the polarity, dipole arise in between carbon and oxygen. So the molecule become polar. Is it fine?
Okay.
Hmm. Now, method of preparation. So when we talk about method of preparation, method of preparation. Preparation. So we have some method where we can synthesize only aldehyde. We can synthesize only ketone. We can synthesize both aldehyde and ketone. So here first we'll see that preparation of both aldehyde, aldehyde and ketone. Here, then after we'll see the preparation of only aldehyde, only aldehyde, and then we'll see the preparation of only ketone. So in the case of aldehyde and ketone, we have a popular method by oxidation of alcohol by first, second, third. So the first one is by C from alcohol. When we talk about alcohol, so by oxidation, dehydrogenations we can do. And then we have uh, just let me write only two method. One is alcohol. In alcohol, two thing is there. By one is by oxidation, another is uh, dehydration or eliminations. Dehydro, dehydrogenation, and then after hydrocarbon, from hydrocarbon.
Sir,
So when we, yes,
sir, dehydrogenation means reduction, right?
dehydrogenation means removal of hydrogen. Dehydrogenation means removal of hydrogen is always oxidation. Dehydrogenation, hydrogen. Addition of hydrogen is reduction. But
Oh, yes.
D means eliminate. So this is also oxidation, type of oxidation,
Okay.
metallic oxidations. Now hydrocarbon. So in the case of hydrocarbon, we have alkene and alkyne both. So from alkyne. Clear? Now,
Yes.
after this, only aldehyde. So from only aldehyde, we have hydrolysis method. First, by hydrolysis and then reduction. First, see the reduction. So, reduction. So, reduction of acyl chloride. Reduction of acyl chloride. Here, this reduction of acyl chloride. First, second, nitrile. Nitrile means cyanide. Third, ester. Ester. So, acyl chloride, nitrile, and ester. So, we have to use reducing agent, and here reducing agent will be used hydrogen with palladium and barium sulfate. If you are taking this one, so this is called Rosenmund reduction. If you will
Yes.
use this reducing agent, so it will be Rosenmund reduction. And if you are taking a reducing agent like SnCl2, SnCl2 plus HCl, so this is called Stephen reduction.
Sir,
Stephen reduction.
it's thionyl chloride, right?
What?
I
Stannous
said
chloride.
means thionyl
Stannous
chloride.
chloride. Yes, yes. And then Debal, Debal H. Debal H, it means diisobutyl aluminum hydride. This is also one of the reducing agent. So you can use any one of the reducing agent to reduce the either acyl chloride, nitrile, or ester. Then we have the second method for the preparation of aldehyde. The second method we have by oxidation.
Yes.
So oxidation means you can take it methyl benzene, methyl benzene. Either means you can take oxidation of methyl benzene. It means toluene. Clear? And then methyl benzene and then Gutterman-Koch reactions. Gutterman, Gutterman-Koch reaction. It's a very important. It's a oxidation of benzene. Here, benzene will be oxidized into benzaldehyde.
Yes.
Am I clear? So we have two methods, only reduction and oxidation for the synthesis of aldehyde. And when we talk about the ketone, in the case of ketone, the Grignard reagent is famous reagent And this reagent is always used in the synthesis of any carbonyl compound. So we can use first from acyl chloride and Grignard reagent. So Grignard reagent. What is Grignard reagent? Can you tell me?
RMGX.
RMGX or ARMGX. So Grignard reagent we will use with acyl chloride. We will use it with nitrile cyanide, either cyanide, and that also we can use it. And
Okay.
the second one is acylation, Friedel-Crafts acylation. Friedel-Crafts acylation method. By this method, we can prepare this ketone. Am I clear?
Okay.
So this is the flow chart where you can see the method of preparation of aldehyde and ketone, both. So the first one is what?
First one is oxidation preparation of aldehyde.
First one is hmm. So aldehyde and ketone both. So
So that is a general method, right?
yes, aldehyde and ketone both. We can prepare aldehyde and ketone both. So
Okay.
by oxidation of alcohol, aldehyde and ketone are generally prepared by the oxidation of primary and secondary alcohols. You can see the first one is from alcohol. So here the primary alcohol give aldehyde and secondary alcohol always give ketone. You take, suppose this is CH3 and this is C double bond O, sorry, not double bond, CHOH and this is H. This is ethanol. This is ethanol. When you do the oxidation, so you have to obviously you have to use the oxidizing agent. Am I clear? So you can use the mild oxidizing agent. Don't take it strong oxidizing agent. Otherwise, you will get carboxylic acid as the final product. So here, mild oxidizing agent you can use. Mild oxidizing agent can be used. Mild oxidizing agent, if you are taking potassium dichromate, so it should be very, very diluted, not concentrated, or PDC, PCC, copper, and so many more are there. Jones reagent. Here, let me write. Here I am writing mild because in every chapter this will help you. Mild oxidizing agent. So you can take it K2Cr2O7. Sulfuric acid should be very, very dilute and cold. If you will take it concentrated, so it will be strong oxidizing agent. Other also you can take it Jones reagent. Jones reagent, very, very important reagent. It's a mixture of chromium oxide and H2SO4 and acetone. And even you can use PCC, pyridine chromyl chloride, pyridine chromyl. Also you can use PDC, pyridine dichromate. Pyridine dichromate means this is chromium oxide with pyridine. Pyridine. Clear? And
Yes.
PCC, Its full name is pyridinium, pyridinium dichromate, dichromate, pyridinium dichromate, and PCC is pyridinium fluorochromate. So if you are taking any one of the reducing agent, so here one more is there, that is a copper at 573 Kelvin temperature is also mild. So if you are taking any one of this mild oxidizing agent, so they will produce only the oxygen, and this oxygen will oxidize CH bond, and now it becomes CH3, COH. This is OH and this is H, and this is unstable. You can see that two OH group cannot present on the same carbon. Two OH group cannot present on the same carbon. They will interact together and HOH H2O will be eliminated. So if H2O eliminated, so you will get CH3 C double bond OH, which is aldehyde. So if you take primary alcohol, so product will be aldehyde. If you take the secondary alcohol, CH3 C OH H CH3. And if you are taking the same reducing agent, so this oxygen will get here. So you will get CH3, COH, OH, and this become unstable because two OH group cannot present on the same carbon. So they will interact. This is H and OH. H2O eliminated. So minus H2O. So you will get CH3, C double bond O, CH3, which is ketone. So secondary alcohol. Why this is secondary alcohol? Because OH group present on this carbon which has two side carbon chain. So this is secondary carbon. Are you getting what I'm trying to say?
Yes, sir.
Yeah. So this is the way by which you can get it. Pyridinium. Here I'm writing pyridinium fluorochromate. Fluorochromate. So this is the way by which you can prepare it by oxidation method. Any confusion?
No, sir.
So now dehydrogenation. Next one is dehydrogenation of alcohol. Dehydrogenation of alcohol. Dehydrogenation of alcohol, that is also called as catalytic dehydrogenations. How it is? Because you can see it that if aldehyde is heated, like if I'm taking R C H H 2 OH, and if you are taking catalyst like copper at 573 Kelvin temperature, so when vapor of primary or secondary alcohol is in vapor state are mixed with the air, okay, and passed over the copper at this temperature, you can take the silver also, either copper or silver at 573 Kelvin temperature. So primary alcohol are dehydrogenated to the aldehyde and secondary alcohol will give the ketone. So here air is also there. So if air is there, so they will provide the oxygen, and that oxygen will form water molecules. So here hydrogen is eliminated. So this is called a uh, dehydrogenations. It's become H2O. And this is RC double bond OH, which is aldehyde. So this is primary alcohol. So primary alcohol give aldehyde, and if you take the secondary alcohol like R, C, R dash, H and OH, and if you are taking copper at 573 Kelvin temperature, so in the presence of air, these two hydrogen atom will be eliminated. So hydrogen atom will be eliminated with water minus H2O. So you will get RCR dash double bond O, which is ketone. So secondary alcohol always give ketone, primary give what?
Uh,
Aldehyde. Primary will give aldehyde. Have you got it?
yes, sir.
Now third method is what? This is about the oxidation. Third method is ozonolysis. Ozonolysis of alkene. So when we talk about alkene, so alkene always have double bond. This is alkene. You can see that it's an alkene. This is alkene. So alkene react with ozone in the presence of zinc. Okay, so you will get, you can see that zinc react with oxygen to form zinc oxide. Now there will be two oxygen, and two oxygen will break this double bond, and you will get C double bond O, C double bond O this side, carbonyl compound. Have you got it?
Yes, sir.
Suppose if I am writing CH3, CH2, CH double bond CH2, and there is ozone. So you will get zinc oxide. So out of three oxygen, two oxygen is left out. So two oxygen will break this double bond, and you can put the oxygen along with the double bond. It will be CH3, CH2, CH double bond O, and plus CH2 double bond O. So this is, both are the aldehyde. You can see that this is also aldehyde, formaldehyde. One carbon aldehyde is formaldehyde, and three carbon is propanaldehyde. Propanaldehyde. So this way you can prepare it aldehyde. If you will take highly branched, so you will get the ketone. Have you got it?
Yes, sir.
Hmm. Now the fourth method is hydration of alkyne. Hydration of alkyne. When we talk about alkyne, so alkyne always has triple bond. And if there is addition of water to the alkyne in the presence of H2SO4 and mercury sulfate, HgSO4, in the presence of H2SO4 and mercury SO4, there is a addition of water. So if you break this water, so here you will get minus and plus. And if you break this bond, so this negative part will be added as per the Marconi-Karb's rule. So as per Marconi-Karb's rule, negative part added to this carbon which has less number of hydrogen. So this is RCOH. Now there will be triple or double bond, Isa?
Yes, sir.
There will be double or triple bond?
Uh, in carboxylic acid,
Hmm?
um,
It's R, C, and triple bond. When you break it, so negative part will be added to this carbon which contain less number of hydrogen. So out of triple bond, if you break one bond, so the rest bond will be double bond,
the
CH. and this hydrogen will be added to this carbon, which has more number of hydrogen, so it becomes CH2. There is one again addition because double bond is there. So if this will break, so again you add the water. So this negative part will be added to the carbon which contain less number of hydrogen. This side, this hydrogen will be added to this carbon. So RCOH. Are you getting what I'm trying to say?
Yes, sir.
Now double bond converted to
Single bond.
CH3. So this is stable or unstable? Because same carbon cannot have two hydrogen, OH group. This is hydrogen and this is OH, H2 eliminated. So you will get RC double bond O CH3. This is ketone. Have you got it?
Yes,
If you take hydrogen at the place of CH3, so here you will get, or at the place of R, if you are taking hydrogen here, so you will get aldehyde. You can prepare the aldehyde also. Is it fine? So this is the method for the preparation of aldehyde and ketone both. Any confusion?
no, sir.
So in the next class, I will discuss the preparation of aldehyde, preparation of ketone separately, and then
Okay.
physical and chemical property. Then chapter this part will get over, and we'll do some questions. So the homework is what? To complete the IBSC nomenclature, exercise question number 1, 2, and the in-text questions. Can you do it?
Okay, sir. I'll do it. Index questions only, right?
Yeah. So
Okay, sir.
you have to WhatsApp in the chemistry group because we have started this new chapter. So you have to be alert. Suppose if you wanted to revise this entire topic, which we have done in this 60 minute or more than 60 minute, 1 hour 20 minute. So here you tell me that how much time you require to revise this. Suppose right now you are going to revise the same thing. So how much time you will take it?
Sir, I think half an hour.
So the same thing I'm telling you that in 30 minutes, try to revise it and give more time to revise the previous one which we have done. Am I
Okay.
clear? Yeah.
Okay, sir.
Any other confusion, doubt?
No, sir. It's clear.
So, hmm, so we will have the class. Today is Friday. So when we have the next class?
Sir, next class is on Sunday,
So
according to the schedule.
yeah, so on Sunday we'll have the class, okay, in the evening.
Sir, can you tell me like what is the general timing it will be? So that I have an idea.
General timing for what? Class?
Yeah, class.
So class, is it possible to have the class before 10, at least 9 o'clock?
Yeah, sure, sir. Only
So
because
I
you
will,
told
uh,
actually my
so
class is 6:30. That time also, sorry, 6:30 means India timing, 9 o'clock also, or yeah, like that also you can take.